there is square pyramid, right? So question number 2 you have, that is, it is having a square pyramid, right? And a square pyramid is like this. Six, 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 and six, right? This is the arms of pyramid, right? This is the square pyramid, and its sides are 9 centimeter, 9 units, 9 units. These are base is square, right? And there is there is not visible. Okay, uh, this is the diagonal of a square, right? Is it visible? This is diagonal of square, and there is this is the height of the pyramid, and this is making 90 degree, with this. So property of square is square square in square all sides equal, all sides equal, right? Diagonals are equal, diagonals diagonals are equal, and perpendicular bisector, and perpendicular perpendicular bisectors. Perpendicular bisector means they are like this, you know they are at 90 degree to each other, they are at 90 degree to each other, and they are making half. They all are equal, so all halves are equal, right? And there is a one more formula we have, that is, I said, in square all sides equal, all sides of square, in square pyramid base is square, right? So therefore all sides of the base are equal, they are of 6 units, right, each, and diagonals are equal and perpendicular bisector. The diagonals will be equal and they are perpendicular bisectors, like this, they are perpendicular, so they are perpendicular bisectors. And third property which we use, that diagonal of square is equal to side side root 2, right? So here in square, I said diagonal of squares are side root 2, right? So here square is having given square in given square given square in given square, each side each side each side of 6 unit, right? Yeah. So diagonal is equal diagonal, which is AC, right? Diagonal, that is AC, is equal to 6 root 2. 6 root, diagonal AC is equal to side root 2, that is 6 root 2. Is it? So this is the diagonal AC or side 6 root 2. So AC is 6 root 2. This was your first question. Yeah. Sorry. I forget to put it like that. This is A, this is B, this is C, this is D, right? This is H. Intersecting point is H, and that is O. Fine. Now it's okay. So AC is diagonal, which is equal to side root 2, and side is of 6 unit, so 6 root 2. Yes. Then find the length of OH. So for OH, we have a triangle like this. AHO is a right angle triangle. Here it is of right angle. OH is perpendicular to AH, right? OH OH is perpendicular to AH, right? And H is H is point of intersection intersection of two diagonals. M is point of intersection of two diagonals which bisect bisect each other, right? which bisect each other. This H is point of intersection of two diagonals which bisect each other. So as you said, AC is and AH is half of AC. And as I told you, 1 by 2, 6 root 2 into 6 root 2, so 2 1 is 2 and 3 times 2 is equal to 6, so 3. So AH is 3 root 2, getting? AH is 3 root 2. AH is half of AC. OH, yeah. So now we have we have to find OH, OH. Now, now, yeah, yeah. So triangle, triangle A AHO is right angle triangle, right angled triangle, right? AHO is a right angle triangle. This is at 90 degree. So this will, if one angle in a triangle, one angle is of 90 degree, it becomes right angle. So in AHO, this angle is of 90 degree, so it is right angle, right? By using by using Pythagoras theorem, Pythagoras theorem, Pythagoras theorem, we have, you know, um, OA square. OA square is equal to, means hypotenuse square is equal to AH square plus OH square. OH square. Fine. So OA is 9. So 9 is 9 whole square is equal to AH. That is 3 root 2 whole square plus OH square. Fine. So 9 square is 81 square. 81. Sorry, 9 square is 81 and 3 square is 9. Uh, 3 square is 9 and 2 root 2 square is 2. So 9 into 2 becomes 18. So it is 18. Getting? Plus OH square. OH square. Now you bring this 18 on the other side of equal, so it becomes 81 minus 18 is equal to OH square. So how much we get? That is equal to 81, 81, no, 18. We have taken 7, 13. Yeah, 11 minus 8 becomes 3, 7 minus 63, yeah, 63. So there is 63 is equal to OH square. Oh, sorry, it is 63, not 67. 63. OH square, right? So taking square root both side, we get OH is equal to 63 means 9 times 7 is equal to 63. 9 times 7 is 63 and 9 is a perfect square of 3, so it will come out. So it becomes OH is equal to 3 root 7. Getting? So this is we have OH is equal to 3 root 7. So this is 81. 1 carry 11 minus 8 becomes 3. 97 minus 63. Yeah, yeah. So this is your second answer, right? Okay. Have you done this? Should I rub this part this side? Okay. So find the volume V of a square pyramid. Okay. Find volume of, this is part third. Find volume of square square pyramid. Square pyramid. And volume is equal to 1 upon 3 1 upon 3 into area base area of base into height, right? Into height. So B is equal to 1 by 3 as this is square area of base. So base is square, right? Base is square. So area of square is side square. Area of square is side square, right? Into height. Height means OH. OH. Fine. So yeah, yeah. Is it? Understand? Okay. So now 1 by 3. Now we have 1 upon 3 into each side of square is of 6 unit. So side square will be 6 square into OH is 3 root 7. OH is 3 root 7. Right. OH is height. Height. Right. So this, yeah. It is height basically. Volume is area of base into height. So area of base is area of square, right? And area of square is equal to side square. This is area of square. Area of square is equal to side square, and we put the value of side, that is, and each side of square is 6 units. So 6 square into height we find 3 root 7. So I wrote here 3 root 7. So this 3 and this 3 is cancelled out, and and v is equal to v is equal to 36. 6 square is 36 into root 7. So root 7 unit cube, right? This is the volume of pyramid, and this is 3 root 7 unit. Whatever unit is given, that we will use. So this is the solution of whole question you have. Unit means, unit can be in meters, in centimeters, in millimeters, in, like this. Whatever unit is given, is give there. It is not mentioned there, so I write unit. Okay. Yo. So this is we have done. So should I do this? Now you send me two more questions. Okay. So there is a rectangle. Question number that was two. This is question number uh, second. This is three, we can say, right? Question number three, which is tell me. Okay. So there is given a rectangle ABCD. There is a rectangle ABCD. Okay. So rectangle is like this. This is the rectangle, right? Which is having A, B, C, and D. Just to revise the properties uh, in rectangle, in rectangle, 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 opposite sides are equal. Opposite sides are equal. It means AB is equal to CD and BC BC is equal to AD. Fine. Opposite sides are equal. Vertex angle of vertex angle vertex angle of 90 degree each. 90 degree each. So vertex angle is like this. This angle, this angle, this angle, and this. They all are of 90 degree each. Right? Okay. So now it is given that AB is 12 centimeter. Oh my God. Oh, they have taken like this. AB. Oh, sorry. Vertex are going to be. I wrote. They are saying it is A. This is B. This is C, and this is D. So we can write here AB is equal to CD, that is fine, and BC is equal to ED, that is fine, no problem. Okay, so AB is 12, AB is 12, AB is 12 unit, AB is 12 unit, and AD is 18 units. This is AD of 18 units, right? 18 units, and this is of 12 units. So let the fold EF, let the fold, let the folded line be EF to make vertex A coincide over with the vertex C. So it is folded. It gets folded. When you fold it, you know, then there is a line EF is formed. There is line EF is formed. This is line EF, right? And this A coincides to C. Vertex A coincide to C. So this will be, this is F, this is F, this is E, and vertex coincide A with C, and this is folded, and it is like this, right? So this is B dash, this is B dash, right? So ED is equal to X, ED is equal to X, right? ED is X, so express the length AE, okay, with X. So this AD is equal to 18 unit. You know, AD is of 18 unit. AD is equal to 18 unit, and ED is equal to X. ED is equal to X. So AD is equal to AD is equal to AE AE plus ED, right? And AD is 18, so I write here 18 is equal to AE, we have to find out, and ED is equal to X. So AE is equal to 18 minus X. Getting? AE is equal to 18 minus X. Yeah? Have you done this? Okay. Now find the X by using Pythagoras theorem in a triangle CDE. Okay, I know that. CDE. So we have to find the value of X by using Pythagoras theorem, right? Okay. So this triangle, this triangle, yeah, CDE is right angle triangle, right angled triangle, and so AE will be hypotenuse. AE is equal to hypotenuse that is equal to 18 minus X. 18 minus X, right? And ED, 18 minus X, and ED is X, that is given, and AD is equal to AB is equal to 12 units, right? So AD is equal to AB. No, not AB, this is CD, CD. We are having vertex. This A is overlap, so this is CD, right? CD is equal to CD is equal to AB. Yeah, that is, this is you can say yes. This is C. This is C. Sorry, this is C. C. C is hypotenuse. ED is X, and CD is equal to 12. So now by Pythagoras theorem, by Pythagoras theorem. 18 minus x we find from here. That is equal to same, na? CE is equal to AE because it is overlapping. Yeah, yeah. CE is equal. So I forget to write here. Right. CE is equal to AE. CE is equal to AE. Right. So by Pythagoras theorem, we can get h square is equal to b square plus b square. Okay. So h square is CE and that is 18 minus x square. 18 minus x whole square is equal to perpendicular, that is AD, CD, that is CD, that is 12. 12. So 12 square, 12 whole square plus base is x square, right? So here we will apply the formula of a minus b whole square. Here we will use formula. Here we will use identity that is a plus b. Sorry, a minus b whole square is equal to a square plus b square minus 2ab. Right? So when I use this property here, so it becomes 18 square 18 square plus x square minus 2 into 18x. Yes, 2 into 18x. 18 square will be a plus is equal to 12 square plus x square, right? So now we, yeah, 18 square is 324, right? And this plus x square, and this is on the other side of is equal is x plus x square, they will cancel out. Plus x square. Now we get minus 2 2 times 18 becomes 36. So this is 36x. 36x is equal to 144. 12 square is 144. So now we bring this 144 on this side of equal. It turns to be minus, and we bring this minus 36 on this side of equal. It turns to be plus, right? So we can write it 324 minus 144 is equal to 36x. Is it? Now we subtract 324 from 144. 324 from 144. So we get 0 here. No, we get 0 here. We get it this way. 2, 1, 11 minus 12 minus 4 becomes 8, and 2 minus 1 becomes. It is 180. Okay. So we get here 180. 180 is equal to 36x. Right? So we can write x is equal to, we can write x is equal to 180 upon 36, right? When you multiply 36 by 5, you will get 180. 36 5s are 180. 5 times 36 is 180. So 36 will, so 36 will be 36. 36 5s are 180. Getting? So x is equal to 5. So x is equal to 5. I hope we got the answer. We have to find the value of x. Is it? Okay. So should I rub this? You're doing? Okay. Great. Now we have another question you send me. Should I rub this? Thank you. This is question number uh, 4, right? So this is a circle, right? And this is circle, and this is line. And if circle and line, circle and line has one common point, one common one common point only, then line is called tangent. Tangent, right? So this is the circle and this is the line. Line and circle has one common point only, right? Then it is known as tangent. Then this line is called tangent. Line is called tangent. Got it? Okay. Now this is the center of circle, right? If line and this is center of circle O, and it is joining the common point on the circle, or common point between line and circle, that we call P, right? So this is, we say A. So theorem is line from center, line from center, line from center, perpendicular, line from center, line from center, sorry, line joining, line joining, line joining center of circle, center of circle and common point, common point between, common point between line joining, joining center of circle and common point between tangent, common point between line and circle, line and circle is perpendicular to the tangent, perpendicular, perpendicular, perpendicular to tangent, right? So line joining center of circle and common point between line and circle is perpendicular to the tangent. So this is of 90 degree. I hope you understand. So this is the line OP which is joining tangent PA. P is common point. So this is of 90 degree angle. Right? This is theorem. So you have a you send me the question like this. Uh, there is a circle like this. This is the circle, and its center is O, and line from center this, and there is a tangent, and there is an external point. Yeah. If I say there is an external point P, so they join like this, and line from center to the common point on tangent, right? So this is of 90 degree. This is of 90 degree. So this length of tangent is given as 10 units, and this, uh, yeah, this we called OP, say A, and its OA is 5 units, right? So triangle, triangle, triangle OAP, triangle OAP is OAP is right angled triangle, right angled triangle, and by Pythagoras theorem, by Pythagoras theorem, this is OP square, hypotenuse square is equal to perpendicular square plus base square. So hypotenuse is line opposite to the 90 degrees. So OP square is equal to PA square plus OA square. Right? OP square is x square. X is given as PA is 10 whole square plus 5 whole square. Right? So x square is equal to 10 whole square is 100 plus 5 whole square is 25. So it becomes x square is equal to 125, right? Now taking the square root both sides, x is equal to 25 into 5 square root. 25 is a perfect square of 5, so we can write 5 root 5 unit, right? Yeah. So, so this is 5 root 5. Fine. This was question number 4, part 1. Should I rub this? Which one? There is one more question of circle that we do not want. Okay, let's see. Yeah, you are talking about this question. Mm, But what to find here? Actually, it is not full question in this here. Anyway, I'll try to solve it. No, it's visible, but what we have to find that is not able to understand. Anyway, you tell me something. Yeah, length of AG. Okay, okay. So, hmm, yeah, pardon? Yeah, we have to find EG. That vacuum we can get. Definitely we can get. Okay, should I rub this? So, question number 5, we have there is a you know cuboid. There is a cuboid like this. Yeah, this is a cuboid, right? And cuboid has vertex. There is A, B, C, and D, right? And it is having E, F, G, and H, right? Okay. And it is given us this FB is 5, this breadth is, width is, height is 5, sorry, this is height is 5, height is 5, right? And length is 7, length is 7, and breadth is 4, right? So they had they are saying that there is a diagonal of this base. This base is a rectangle, 7 into 4, right? So when this is 4, this will be 4. So and this is a rectangle, 90 degrees. So we can get this, and this is of 5 centimeters. So this will be this is of 5, and there is another line. There is another line which is joining EC, right? So what we have to find EC, is it? Hello? Oh, I wrote wrong. EG we have to find. EG we have to find. Yeah, this is G. That's a G. E. C. Right. Okay. So this so here will be, this is a right angle triangle, this is a right angle. Hmm? Okay. So diagonal of a cuboid, diagonal diagonal of cuboid, diagonal of a cuboid is equal to L square plus B square plus H square square root, right? So that is equal to diagonal of cuboid. This is diagonal of cuboid. So EC is equal to diagonal of cuboid, that is EC. So that we use square root. L is 7, 7 is square. L is this length, FG, and this B is GH. Breadth is GH. That is 4. That is 4 square. Oh my God. That is 4 square plus H is 5 square. So 5 square. Fine. So what we do, 7 square is 49, 4 square is 16, plus 5 square is 25. We take square root of all this. So how much we will get? That is 46. 49, 16, 25. So 9 plus 6 becomes 15, 15 plus 5 becomes 20, 0, 2. Yeah, yeah, yes. 4 plus 3 becomes 7 to 9. It's 90. Fine. So 90 root, right? So 90 square root 90 can be written as 9 into 10. Yeah, you go ahead, go ahead like this one. The root 90. Fine. No problem. Root 90. So EC is root 90, right? This is EC. Sorry, this is EC. EC. Fine. EC. This is EC is root 90, and this GC is, so in triangle EGC by Pythagoras theorem. Pythagoras theorem this is hypotenuse. So EC square is equal to EG square, EG square plus GC square, right? So EC is root 90. So root 90 whole square is equal to EG square plus GC is 5. So 5 whole square. So it becomes 90, and this is 5 square is 25. That goes on the other side. It becomes in minus. So 25. So EG square, right? So 90 minus 45, 90 minus 25 is 65. 65, yeah. What happens? Yeah, EG square is 65. Taking a square root both side. So EG is equal to 13 5s 13, 5 times 13 is 65, right? And 13 is a prime number and 5 is also a prime number. So we can't do anything. It remains root 65, right? So EG is root 65, right? So this is sufficient for today. Okay, sir. Thank you. Good day. Yeah.